Juliana is head of communication of at Seven. She holds a degree in the industrial and management engineering and an executive master in digital marketing. Uh, she is specializing in facilitating the energy transition for high energy consumers. Juliana blends her expertise in engineering with her passion for digital marketing to demystify complex energy concepts across various sectors. So, Juliana, we are willing to hear you speaking about direct combustion heat products from Sivan.
Can everyone hear me and see the presentation?
Yes, we
Yes?
are.
Okay, hi, good afternoon. I'm Juliana. I work at Sivan, where we focus on innovative energy solutions for high-intensive energy users, but we will dive into that a little bit later. So during this presentation, we are going to talk about direct heat production boilers. However, we are going to focus on biomass boilers because these are Sivan's expertise. And they also play a major role on the energy transition nowadays. So we are going to start with a market overview and challenges, talk about also biomass value chain and circular economy, and a little bit about Sivan as well. So as we all know, direct heat combustion boilers work by burning fuel to produce heat, and this process can be used by various types of fuels, including biomass, natural gas, coal, oil, and others. But today we're going to discuss a little bit about the transition of direct heat combustion boilers to renewable fuels, especially specifically biomass boilers. So when considering direct combustion heat boilers, these include those fueled by fossil fuels, such as natural gas boilers, where they burn natural gas to produce heat and are known for their convenience and relatively lower emissions within the fossil fuel category. In the European boiler market, natural gas boilers actually dominate, holding more than 50% of the market in data from 2022. This is largely due to their efficiency and the infrastructure for natural gas distribution nowadays. Also, another fossil fuel example boiler, it's oil fire and also coal boilers. These are common where natural gas is not readily available. So oil fire boilers use heating oil stored in a tank and are typically found in areas where the gas network is less developed. They were once the backbone of industrial heating. However, they are less common now due to environmental concerns, but they're still used in some industrial processes in regions where coal is abundant and inexpensive. Coming back to biomass boilers, including wood pellet, wood chip, wood log, and straw boilers. These are popular for their renewable status and are used in a variety of settings, from domestic to industrial. And actually small-scale biomass systems can help provide electricity to rural areas and businesses. And bioenergy aligns with the principles of the circular economy, where biological waste and byproducts from agriculture and industry can be transformed into useful energy, closing the resource cycle. I'm also going to mention very briefly municipal solid waste boilers, where these burn non-recyclable municipal waste, play a role in waste management and energy production as well. And they are part of a strategy for urban areas. There also exist coal firing boilers where they mix a coal or another fossil fuel with biomass. But as I have mentioned, we are not going to be able to discuss every type of direct combustion boilers today. So today we're going to focus on biomass boilers and their fuel, which are one of Civilians' expertise, and discuss its benefits as well as its challenges. So we're going to start with talk about a little bit of the European market overview. And so in the specific case of Europe, some endogenous factors which drive the bio-based economy in the EU. Among others, we have an abundance of natural and biological resources that fuel the bio-based industry. We also have a strong primary economy sector that can benefit from the technological development for increasing productivity. And specialized higher education, as well as research and innovation activities that can increase knowledge on innovations for the bio-based economy. So as we can see, the Europe biomass boiler market size was valued as $10.1 billion in 2023 and is estimated to grow at over 7.8 CAGR, which is the compound annual growth rate, from 2024 to 2032. So reaching the market value of $20.1 billion in 2032. The agricultural waste biomass boiler size in Europe is set to surpass $1.5 billion by 2032, as governments and organizations across the region are increasingly focused on renewable energy sources to reduce greenhouse gas emissions and to combat climate change. Ongoing advances in the boiler technology also include improved combustion efficiency and reduced emissions, and make these boilers even more attractive for business and industries, which you can see as well as the industrial boiler market share was 30% in 2022. So a little bit about the global market overview. So a report published in June of 2023 based on the feedstock shows that the global market is segmented as woody biomass, agricultural waste, industrial waste, urban residue, and others. So the woody biomass boiler market will witness 88% growth rate up to 2032 globally. So it's about the rising demand for the renewable energy, as I already mentioned, and the strong focus on the decarbonization will drive the product deployment across wide application areas. So let's not forget that COVID also had some impact and disrupted some industrial operations and supply chains, leading to a significant decline in the biomass boiler business worldwide. And what about the challenges in the implementation of this technology? So I identified two. So the first one I'm going to talk about is the high initial investment. While the adoption of the biomass boiler technology offers a sustainable heating solution, one of the main hurdles remains that the high initial investment required is still very high. So this upfront cost can be a significant barrier for many businesses and organizations. However, innovative financial models such as energy as a service are emerging to ease this burden. Energy as a service allows customers to enjoy the benefits of energy upgrades without the initial capital expenditure, as costs are covered by savings generated over time. Additionally, various government initiatives are available across different European regions, which can further help offset these initial costs. These financial supports vary wildly, but generally aim to make green energy technologies more accessible and financially viable. About the fuel availability, it's a critical factor for the efficient operation of biomass boilers, which hinges on a robust supply chain. In Europe, it involves the complex logistics and management of sourcing, processing, and delivering biomass materials like wood chips, pellets, and agricultural residues. So the challenge extends beyond mere transportation, encompassing the entire supply chain for raw materials, collection to the end user delivery. So the diversity of Europe's geographic and climatic conditions further complicates the biomass supply, requiring adaptable and resilient supply chain that can be reliable and meet regional demands. So here we have the biomass value chain. As we can see, the biomass value chain has several components from the land use into the end use. However, I want to focus on the farmers and the foresters that play a crucial part in this new bio-based value chain. So biomass, in its broadest definition, comes from the forestry and agricultural resources, as well as marine. And as from its industrial processing and biological wastes arising from various sectors of society. So farmers and foresters are critical and essential stakeholders in the bioeconomy, yet much of the initial development of the bioeconomy took place without their input. So the bioeconomy will not be socially sustainable without the buy-in and benefit to those stakeholders. Farmers that are organized into cooperatives that extend their business from farm to market have a competitive advantage with regards to moving to the bio-based industrial sector. They can inherently assess and inform the entire value chain for feedback, loop exchange, or knowledge for primary production to processing, and from processing to primary production. So by contributing to refining and optimizing the sustainable production of biomass suitable for upgrading to higher value products, farmers earn the license to be valued partners in the value chain. And they can make multiple contributions to a sustainable circular bioeconomy through innovation of agricultural practices. I'm going to talk a little bit about the circular economy in waste management. So the integration of biomass boilers into business operations, particularly for industries that produce organic waste, offers a technical and environmental strategic solution. So business such as wood processing mills, agricultural operations, and food processing plants often generate substantial organic byproducts. So instead of discarding them as waste, they can be repurposed as fuel for biomass boilers and turning a disposal problem into an energy solution. However, from a technical perspective, integrating these systems also requires consideration of the logistics and infrastructure needed to collect, store, and feed into these boilers, as they need treatment and everything. So I'm going to talk a little bit about Civin. So as I've mentioned before, Civin focus is to facilitate the energy transition for intensive energy consumers, but how do we intend to do that? At Civin, we saw an opportunity and a necessity to update the biomass boilers to our time. So in a way to make that transition from old fossil fuels boilers to an updated, better system capable of reducing cost and hassle-free, as simple as installing a gas boiler. That is which is one of the major obstacles regarding the biomass boiler adoption. Civin boiler is in its final stages of development. It's designed to be a class 5, the highest in terms of efficiency and emissions control. compatible fuel type for now, it's wood pellets, and it's designed for practicity. So everything is automatic, plug and play, from feeding to demand control. So the future range will be from 150 to 500, and the control optimization is going to be up to 95%. It's the effectiveness in managing operations such as fuel consumption, emissions control, and the energy output. On a more technical view, we have the boilers made of carbon steel, except for the burners that are made of ceramic for the combustion control. So the cold water enters the heat exchanger of Stevens biomass boiler at a minimum of 55 degrees and exits heated from the combustion chamber at the set point temperature. The boiler's sophisticated design includes exhaust gases traveling from the combustion chamber under and inside the tubes equipped with turbulators. So these turbulators enhance heat transfer efficiency by increasing fluid turbulence and feature scrapers to clean the tube wall incrustations, which are then collected and removed via an auger. For biomass storage, the system utilizes strategically designed silos that ensure a consistent and automated supply of biomass pellets to the boiler, mirroring the convenience of the natural gas boilers. I'm going to show you a quick comparative analysis, which is, this is a case study from a municipal swimming pool complex with an annual energy need of 1,500 megawatts watt hour. So where here we can see it was actually a big complex on 24 hours. So that's why it's such a high energy needs. So here you can see what happens in a real case scenario in each month with the simple change of natural gas boilers to biomass boilers. In orange, we have the costs associated with natural gas consumption. In green, we have the associated costs with the biomass consumption. And in blue, we have the thermal energy need consumption for each month. So as we can see, it's the same energy consumption, but with different fuels, different boilers, that results on significant savings over time. So I want to talk a little bit on conclusion. So we as an industry are helping the public to understand the pros and cons, and we must continue to do so honestly and openly. Investing in renewable heating system is a huge expense for anyone, so a reasonable payback time is also key for the tech adoption. So to exploit the potential of the European economic system, the concept of the bio-based economy must be integrated with the circular approach. The development of integrated solutions and out-sectors should have a particular attention on energy efficiency, of course, particular attention on agriculture to reduce the overconsumption of raw materials and waste would also pave the way for the sustainability transition to the bio-based economy. On the other hand, on one hand, the transition for fossil fuel resources to bio-based requires a transformative change of the socio-technical system and influences the development of novel technologies for sustainable exploitation of the resources and the awareness of society to environmental challenges and sustainable options. And on the other hand, the bio-based economy benefits from cross-sectoral innovations based also on the cascading approach, which is one of the pillars of the transition to bio-based economy. For this reason, looking at the bio-based sector singularly does not add much to the understanding of the bio-based economy transition. So I'll finish with this phrase from Ralph Sims that most people actually don't understand and don't know biomass. So if people talk about renewable energy, they immediately think of wind and they immediately think of solar. And then after a bit of thought, some might even think of hydro and some might think of geothermal, but biomass is not on people's mind, and that should also change, and that's why we are here. So thank you very much for your attention.